Hi guys, welcome to our first video in chapter 8, which is all about ionic compounds. So this is our first unit that actually is going to show some chemical reactions and some molecules forming, which is awesome. We're getting into the real chemistry. So section 8.1 focuses on general formation of chemical bonds, of course, with the lens of ionic bonding. For this unit, I have a pretty interesting question I'd like you to consider. Why can we melt sugar on a stove but not salt? In order to answer this question, we actually need to understand how the atoms in a sugar molecule versus the atoms in a formula unit of salt are held together. And so what is that force that holds together atoms? Well, here's our first definition, right? That is a chemical bond. So a chemical bond is simply the force that holds two atoms together. This is typically a mutual interaction, and I have this important bullet point written here. In this interaction, when a chemical bond is going to form, the overall stability of the system will be increased. So if we have two atoms, like say sodium and chlorine, when they form a bond, they will be more stable than before they formed a bond. That is why that bond will actually form. So there's four types of bonds that we are going to talk about in this class: ionic bonding, covalent bonding, metallic bonding, and network covalent bonding. Of course, we're going to start today with our ionic bonding, right? So that's going to be the unit that we're in. And so let's jump right into it. Let's start thinking about how an ionic bond would form. So if we consider two very common elements, you need these in your body to stay alive. These things can be found all throughout the Earth's crust. But let's consider the elements sodium and chlorine. So I have down here, there are Bohr models, and you can see the valence electron for sodium is highlighted in red, just so you can see where it actually ends up, right? So to begin, you see that our neutral sodium atom has a neutral charge, as is our chlorine atom. Sodium has 1 valence electron. Chlorine has 7 valence electrons. So, of course, we know from our previous discussions in chemistry, these two things to be true. Sodium wants to lose that electron in order to achieve the stable octet, right? You can see the second ring would be full, where chlorine wants to gain 1 electron. Now, this is great because one wants to lose an electron, one wants to gain an electron. They can work together, and an electron will be transferred from sodium to chlorine to form a molecule of sodium chloride. And you can see that when the sodium loses its electron, of course, it gets smaller because it's now lost an electron. It has 1 less energy level. It is called a cation. When we think about chloride, that is an atom that has gained an electron. So now it's an anion, right? A negative ion. And it's hard to see because I don't think it's drawn this way, but you can imagine putting in 1 extra electron is going to make this atom a little bit larger. So we have on our ionic bonding, wait for it, 2 ions. What? Oh, that's crazy, right? So the idea of ionic bonding is a bond between 2 ions. And I'll actually define this in the next video. But the electrostatic force between this positive charge and this negative charge is what holds together our ionic compound. So let's think about how we would draw Lewis diagrams for these 2 particles. So to begin, of course, I'm going to begin with my sodium and my chlorine atoms. So sodium is Na, chlorine is Cl. I know that my sodium has 1 valence electron, so I'm just going to put that one on top. Actually, I'm going to do this just like we did in the example. I'll do that in red. So we've got our sodium, and our chlorine is going to have 8 valence electrons. 1, 2, 3, 4, 5, 6, 7. I'm sorry, I just said it would have 8 valence electrons. You guys, of course, know that it instead has 7 valence electrons because it wants to gain 1. Well, there is going to be, if these things are next to each other, a transfer of electrons where my sodium will lose an electron. And so I'm going to form a sodium with a positive charge. And in order to draw the Lewis dot diagram for an ion, I'm going to do 2 things. First, I'm going to include square brackets around my symbol. That indicates that there is a charge. Since my sodium lost electrons, it lost all of its valence electrons, I'm going to show the symbol with no electrons around it, indicating that those valence electrons were lost, and a positive charge above it. So we have sodium with a positive charge. Now let's draw our chlorine, right? So again, it's going to be an ion. So I'm going to have those square brackets and Cl for chlorine. Now, chlorine was gaining electrons. So it has its 7 original electrons, 7 original valence electrons, plus it has the valence electron from sodium also on it. So we can see in this example, we also have a stable octet. And of course, we get the -1 charge. And I do want to highlight that for both ions show a stable octet. And you can see that easily in the negative ion because it has 8 valence electrons. Know also that for the sodium, because it has no valence electrons, that means it's lost all of its outside electrons and it has achieved stability by forming a positive ion. And there we go. We've drawn our first Lewis dot diagram for an ionic compound. And in fact, this is how we're going to start to represent our ionic compounds. Now let's consider the electron configurations for these two things. So for sodium, I see that it's in the third row. So sodium is 1s2. We'll do Na, right? We have 1s2, 2s2, 2p6, 3s1. And I'm going to highlight our valence electrons, right? So that's our outermost electrons. When we go to Na positive, right? We have 1s2, 2s2, 2p6, and we've lost our electron. Lost the electron. Cool. When we do our chlorine, right? We have 1s2, 2s2, 2p6, 3s2, 3p5, and our chloride, our Cl minus, is going to gain an electron. So 1s2, 2s2, 2p6, 3s2, and my 3p5 will become 3p6. And I am, of course, going to highlight our valence electrons, and you can see we go from 7 to 8 total valence electrons. Gained electron. So we can represent the increased stability of sodium chloride using our Lewis dot diagrams, our Bohr models, our electron configurations, or even just logic. But that's it for our intro to ionic bonding. Thank you for listening, guys, and I'll see you in the next one.